In this video, I want to demonstrate how to check for normality in HAL. Here is the HAL Studio. So whenever you open your HAL Studio, the first thing you are expected to do is to set your working directory. Now I want to set my working directory because I'll be using a prepared HAL script. I already have my HAL script prepared, and I already have my folder where I put my data set and the R script I want to use, and this here is the folder. Now I'm going to set this folder as my working directory in HAL. I'm going back to HAL Studio. Now to set the working directory, I go to Session, then set working directory, and then choose working directory. Now we check if I'm already in the right folder. You can see I'm already in the right folder. Here is the folder. But assume I'm not in the right folder, so I know that the working directory I want to work with is on my desktop. So I will locate it, desktop, then the name is inferential statistics, then then I have inferential statistics training. That is the working directory I want to work with. Then I click on it, then I click open to set my working directory. Now you can see here I've already set my working directory. So this is the code to set working directory. Now the next thing is that I want to load the out script. Then I go to file, then click open. Because I've already set my working directory, once I click open, it will take me to that folder. You can see that is why it's very important to first set the working directory so that it will, whenever I want to check anything, it will take me to another folder. And if I save anything, it's going to be saved directly into this folder because I already set it as working directory. Now, the script I want to work with is called it's named Normality check. You can see. So I click on the script, then I click open. You can see here is the script. Now I want to copy this code and copy this code in case I want to use it next time, so that I won't need to go to session. I will just run this code whenever I want to set my working directory. So I have this code. Next time if I save it, let me press Ctrl S. If I save it, so this code has been saved as part of this script. So next time I don't need to go to session, then set working directory, then choose working directory. I just need to run this code by just clicking anywhere on this line of code and click run. So it's going to do the same thing for me. Now the working directory has been set. Now the next thing I want to do is that I want to import data set I want to use for this demonstration, and the name of this data set is mice. It's mice. To import the data set, because my data set is saved in CSV file. So the function I'm going to use, the R function I'm going to use is R-based function. It is called read.csv. That is the function I'll be using. Then in the brackets, I'll put the argument. The argument I'm going to put is the name of this file. That is what I use to save the file. Let me go back to that working directory here. So here you see mice. This is it. You can see the exact name I used to save the file, mice. But because it's in CSV file, it's going to be mice.csv, so that how we recognize that that file is in CSV. So now read.csv. Then in quotation I put mice, the name of the data set, the name I used to save it in my working directory, .csv. Then everything in inverted comma. You can see I'm assigning this file, this data set, to dhelp, that's data frame. Wherever I call this data frame, so I will have my data set. That's what it means. Now if I run this code now, is going to help me to import my data set. Now, you can see here in the environment here, it has shown that the data set has been imported. You can see telling me that in my data set I have 10 observations and 2 variables. I may want to view this data set. I will just, to view data set, I just click on this line of code, that's line 10, view df. Why am I using df? Because df is the variable I assign the data cells to. The importation of data set, I assign it to what? This df. So I just use the function view. It's an arrows function view. Then I put the name df in the bracket as the argument. So once I click on it, that will bring my data set. Now it's come. You can see I'm able to see my data set now. This is I have name, I have weight. Name is a variable here and weight is another variable. I have 10 observations. So you can see that according to what the information we have in the environment, we have 10 observations and 2 variables, and that is correct. So let me go back to my ask script. Now, for convenience, it is always advisable to attach the data set, so that whenever I want to make reference to any variable, so I won't need to make reference to the data set as a whole again. So ordinarily, if I want to make reference to weight, I will ordinarily I will type df, then I put dollar sign, then I can pick any of the variable, maybe weight. But if I attach this data frame already, this data set, I don't need to use df slash, I don't need to use df dollar again to call upon any of the variable. That would make me to bypass df dollar there. So I'll just need to write weight. Okay, no, so that's what it means. Now let me attach. So once I attach, you can see it has been attached. So this is attached. Okay, now meaning that we have been able to attach this df. Okay, now after attaching the df, so it's not time to test for normality. So to use the first approach we want to do is visual inspection. We want to use graphical method to check for normality. So we'll be using ggplot and we'll also be using histogram to check for normality of our variable, that is the weight of mice. Now, and the package we will need is what gg pop out, that is the package we're using. So if you don't have the package installed on your if you don't have the package installed in your app, you can just come to package here, then install, then you look for the name of the package, gg pop out. So then you can now click install and wait until it is installed. Having installed it, you can now load it using library. This library, then in bracket you put the name of the package. Now let me run that. So why am I using this package? Because there's a function in this package. Okay, this function is QQ. There's a function in this package. This function is ggqqplot, and it's going to give me a very beautiful graph. That is why I'm using it, and it's very easy to interpret the information. Having loaded the package, now I've run this line of code, line 15. Now, in order to draw this ggplot, so you can see I only write weight. Ordinarily, if I've not attached my data frame, that is the data set, if I have not attached it, I will have written the dollar weight. But because I've already attached it, I can bypass the okay. Then, and that's the variable I want to check is normality. Then main, that is the title. The title I want to appear on my graph. Now, let me run that line of code, line 18. If I run that, so I'm going to have a plot. You can see this is the plot. Okay, let me expand this. Okay, I can zoom it. I can zoom it by clicking on zoom here. You can see it's coming up. Now, you can see that most of the data points here, 1, 2, 3, 4, 5, 6, 7. Okay, this 7 lies with the exception of this one that lies what outrightly outside this. So with this, we can see that a variable here, that is weight of mice, is normally distributed. It's normally distributed according to the information we have here. Okay, so we are going to look at that point whether it lies, okay, or very close to this line, this theoretical line. You see, if it's close, so we assume it is normally distributed. That is for Kiki plot. So now we go to another alternative way, that's not another alternative visual inspection. We can use the use of histogram. So we are going to do the same. See, I mean the function we remember the function we use here is GG Kiki plot. That is the function that helps us to draw this. But the function we are going to use in using and drawing histogram is hist. You can see hist. That's what we are going to use. Then the first argument in the bracket is going to be the name of the data set because we can already attach it, so we don't need to write df dollar weight. So we just weight, then comma, probability. We say probability is true, okay, that is we want density. So then main, that is the title. So if I run this line 29, so I'm going to have my histogram. You can see density, that is the problem because I put probability is true, that's why I put density here. You can see, so apart from, with the exception of this one that is outside here, you can see that's very far from the rest. Okay, that's the observation we observed earlier in our Kiki plot. You can see we can assume that this show normal distribution. Okay, that we assume that this weight is normally distributed. You can see weight is normally distributed. Okay, now that is for visual inspection. So now moving to format test. There are two format tests that are popularly used, but the one that is recommended is a Shapiro test. So we have Shapiro test and we have Kolmogorov test. So the one that's recommended is Shapiro test. Okay, so Shapiro test. So the function I'm going to use is an R-based function. That is Shapiro.test. Then I put the name of the variable there. So if I run this, look at it. If I run this, I have my result here. I have my result in my console here. So I just check the p-value. So we are not expected to reject the null hypothesis. You can see this p-value 0.38 is greater than 0.05 level of significance. So since this one is greater than 0.05, so we cannot reject the null hypothesis of normal distribution. So the normal hypothesis for this test is that the data are normally distributed. That is, this weight is normally distributed as a variable. We cannot reject that null hypothesis. It means that we are going to assume normality test. We can see whether we use visual inspection or format test, we arrive at the same conclusion that our data are normally distributed. Thank you. See you in the next video.